Hello everyone, welcome to the class. I hope you're all doing good and you're enjoying learning physics with me. I hope you have seen all the lectures on basic mathematics and you have seen all the concepts and theories that we have learned in this chapter. Let's go ahead with some basic problems of basic mathematics which will entail us in problem solving in coming chapters. The first question is based upon differentiation. Let's see here. Find the derivative of y equals to x power minus 3. Now, if you remember, I told you the formula for y equals to x power n. If you want to find its differentiation, you are going to write dy by dx is given as nx power n minus 1. The same formula has to be applied here. We are provided with y equals to x power minus 3. Here n equals to minus 3, so go ahead and put up the value of n equals to minus 3 and you can use the formula dy by dx equal to nx power n minus 1. So we are going to obtain dy by dx for this function. N, you bring it here, that is minus 3, x to the power minus 3 minus 1, that is minus 3 x power minus 4. This is the answer of differentiation of y equals to x power minus 3. It's quite easy. We have to only apply the formula for y equals to x power n and differentiate it. You're going to get dy by dx equal to nx power n minus 1. Here n equals to minus 3. So what I have done, I have seen the function, we got n equals to minus 3. I have substituted n equals to minus 3 and the final result is dy by dx equal to minus 3 x power minus 4. That's quite simple, quite obvious and very simple to reach on this problem. Solution. Now let's go ahead with the second one. Now for the second question, we want to find out the derivative of y equals to 4x power 4 plus 6x power 3 by 2 plus 9x. Again, a simple problem. Here we have several functions in addition with each other. You see one function, second function, third function, all are added. Only thing we have to use individually the formula, that is y equals to x power n. So let's go ahead, let's use them. So y equals to 4x power 4 plus 6x power 3 by 2 plus 9x. So let's directly write dy by dx. When several functions are in addition, you need not to worry, you have to differentiate each of the functions separately and you have to write their values separately and you have to add them. So for here 4x power 4, if I differentiate it, I'll be getting, keep 4 as it is, now x power n formula, 4x power 4 minus 1, that is 3. So I'm writing directly x cube plus 6, 3 by 2, you bring it here, 3 by 2 and x power 3 by 2, so x power 3 by 2 minus 1, that you'll be left with 1 by 2 plus 9x. 9 is the coefficient, keep it as it is, it's a constant, and differentiate x. Differentiation of x is 1, so I'm going to keep it as 1. So the resultant answer that I'll be obtaining, 16x cube plus 6 into 3 by 2. Now see, 2, 6, 3 into 3, 9. So 9x power 1 by 2. This is what you're going to obtain, plus 9. This is the resultant of derivative of this function. So what we did, we simply applied the formula y equals to x power n everywhere and then we got the result. We added all the functions separately and this is the answer for differentiation of this function. I hope that you would have obtained the solution very well. The answer is 16x cube plus 9x power 1 by 2 plus 9. The formula used was again y equals to x power n. Use the same formula, you'll get dy by dx equal to nx power n minus 1. That's simple, easy. Let's go ahead with the next one. Let me rub this and let's obtain the solution for the next problem. The next problem comes here, the third question. Find the derivative of 9x power 5 divided by x minus 3. Here the problem is different, we have to use a different formula. Now before starting the solution, let me give the formula. If the function has two functions in division, y equals to u by v. Now if you have to differentiate dy by dx, what you have to do, you got two functions and both are in division. I told you the formula used will be draw a division line, divide by v square, then v into du by dx minus u into dv by dx. This is what I have told you while telling you the formula for differentiation of a function when two functions are in division. We are going to use the same formula here. Here u is 9x power 5 and v is x minus 3. If I write separately in this problem, u is 9x power 5 and v is going to be x minus 3. So can we directly use the formula? Yes, we can use it. Let's go ahead, let's put up all the values and differentiate them. We are going to get the result quite simply. So I'm going to use this part of the board. I hope that you can clearly see this part of board. Here we have the function is given as y equals to 9x power 5 divided by x minus 3. Now go ahead, put up the values. Dy by dx, first of all, in denominator you have to divide it with x minus 3 whole square, not a problem. Now keep the denominator as it is. First differentiate the numerator. 9x power 5, 9 the coefficient, keep it as it is, x power 5, 9, 5 will be here, and x power 5 minus 1, that is 4. Go ahead, now you have to keep the numerator as it is, 9x power 5, and differentiate the denominator this time, x minus 3. First differentiate x, then 3 differentiation will be 0, so this will be only 1. That is simple result. So finally the answer that we will be obtaining, 9 into 5, 45, 45 x power 4 multiplied with x minus 3 minus 9x power 5 divided by x minus 3 whole square. If you are thinking to simplify it further, yes, you can simplify it further. X power 4 can be taken as common and 9 also can be taken as common. So the final result will come out to be, you may take 9x power 4 as common. So you're going to be left with 5x minus 3. So I'm keeping it 5x minus 3 here. Let's go ahead, keep it as 5x minus 3. Now minus 9x power 5, I have taken x power 4, it will be coming out to be x, and divided by x minus 3 whole square. If you are thinking further to simplify it, again, yes, you can see that we can simplify 5x minus x, you will be getting 4x, and 5 into minus 3, you will be getting minus 15. So let's write the final answer that will come out to be 9x power 4, and here 5x minus x, you are going to get 4x. So 4x and minus 5 into 3 minus 15. This is what you are going to get. Let me write the final result in very simple form here. So we got the final result as 9x power 4, 4x minus 15 divided by x minus 3 whole square. I hope that is pretty much clear to you all what you have done. We have simply applied the formula for y equals to u by v. Let's have a very quick recap of this. See here, y equals to u by v. First, keep the denominator here, differentiate the numerator, minus keep the numerator here, differentiate the denominator, divide by whole square of the denominator. Go ahead, we got this function u and v. Now what we saw, first I have to differentiate this. You are getting 9 into 5, 45 x power 4, and I will be keeping the denominator as it is, x minus 3, minus keep the numerator as it is, differentiate the denominator. Now I saw that this can be written as 9 to 5, 45 x power 4 into x minus 3, and here I had minus 9x power 5 divided by x minus 3 whole square. What I did, I took 9x power 4 as common, so I'll be left with 5x minus 3, which I wrote here, minus, again I'll be left with here only x, so minus x divided by x minus 3 whole square. Very simple form, you can reach it here. You can write 5x minus x, you'll be left with 4x, so 4x minus 15, and outside 9x power 4 divided by x minus 3 whole square. Simple question, not too tough. I hope that you would have taken it down. Let me rub it and let us proceed with the next problem. Now I believe that the concept of differentiation and how to differentiate functions you all would be very much clear with, and already we have practiced a lot of problems earlier also. Now hope that after this lesson, after this class, you are going to find it very easy for you all to solve problems on differentiation. Let's go ahead. Fourth one, the area of a circle is given by a equals to pi r square. We all know that area of a circle is a equals to pi r square, where r is the radius. Calculate the rate of increase of area with respect to radius. Now see here, we all know that whenever the radius is going to increase, the area is also going to increase. But how will be the rate of increase of area is dependent upon the rate of increase of the radius. How to find out that? Yes, differentiation is going to help us in this. Now see how differentiation will help you in this. I told you dy by dx is nothing but a rate measurer. dy by dx, in the very first go I told you it is nothing but a rate measurer. That is, it tells us with what rate y changes when x changes. If x is changing at a certain rate, then it will tell you dy by dx will entail us the understanding of how y is going to change when x is going to change. So dy by dx is rate measurer. Now here, instead of y, we have area A. So A is equal to pi r square. This has been provided. If I differentiate A with respect to the radius r, if I differentiate this, I am going to get this as 2 pi r. Quite simple. That is, rate of increase of area with respect to radius is linearly dependent on rate of increase of r. That means if I draw a curve between dA by dr and r, what I am going to get, if I draw a curve between dA by dr and r, I am going to get a curve like this. I will be obtaining this as the curve because we have 2 pi r, that is a straight line curve. So I can write this as the curve. There is no C part, there is no abscissa, which is actually this line is meeting y axis at 0. So I have not drawn somewhere showing any constant that it is cutting with the y axis. Okay, so it's a straight line curve, and that means dA by dr will linearly increase as r increases. It's linearly dependent on r. Hope that this would make you understand how you can say that, or how you can understand the rate measurer, that is differentiation is the rate measurer. Clear to you all? I believe that's quite simple and easy. With this, let's go ahead with the next problem. Easy problems, differentiation is not too tough. Fifth one, again the application of derivative. You see here, the area of a blot of ink is growing such that after t seconds its area is given by A equals to 3t square plus 7 square centimeter. Calculate the rate of increase of area at t equals to 5 seconds. Not too tough question. Here what is happening, we are finding that you have dropped an ink on a piece of blotting paper. Now we know that gradually the area which is actually occupied by the ink, that will increase. The blotting paper will soak the ink, that will increase. Now with its dependence on time is given here. Its dependence on time is given here. So we have to find out how the area is increasing and how it is dependent on time. Let's find out that. Let's reach to a certain value. Area is depending in this way. So if I write dA by dt, that will come out to be, just differentiate this, you will get 6t, that's it. Constant differentiation is 0. So I'm not worried about that, and its unit will be square centimeter per second, because we are actually finding out the rate of increase of area with respect to time. So we got this 60. Now we have to find out, calculate the rate of increase of area at t equals to 5 seconds. So what you have to do, substitute t equals to 5 seconds. So if I put t equals to 5 seconds, I am going to get dA by dt is equal to 6 into 5, 30 centimeter square per second. That is, at t equals to 5 seconds, the rate of increase of area is 30 square centimeter per second. This is what that has been provided with this equation. Hope that you find it easy and understanding. Let's go ahead with the next one. I hope that it will be clear to you all. Area is given, its dependence on time is given. We have simply differentiated area with respect to time, and we got this equation. You go ahead, put the value of time t equals to 5 seconds, you are going to obtain this. That means area dependence on time, or the increase in area with respect to time at t equals to 5 seconds is 30. It will be not be 30 when t is changing. For t equals to 2 it will be different, for t equals to 4 it will be different, for t equals to 6 it will be different, for t equals to 5 it is this. This is what this question entails us, gives us the value. Hope that you are learning with each question and you are also writing simultaneously with me. Let's go ahead. Next question. After learning differentiation, let's do some problems on integration. Integrate x power 2 minus cos x plus 1 by x. Now I told you all while teaching you all about integration, we have got several functions in addition. So you have to integrate this one with respect to x, you have to integrate this one, you have to integrate this one. So each function has to be integrated individually, remember. So I can write the same thing, this can be written as integration of x squared dx minus integration of cos x dx plus integration of 1 by x dx. So we got this. Let's go ahead, let's find the integration value of all this. So what I'm going to get, first one, x power n. If I want to integrate, now see, if you remember, y equals to x power n, and if I integrate x power n dx, if I integrate this, what I'm going to get, I'm going to get this value will be 1 upon n plus 1 x power n plus 1. If you remember, this was the final formula, and plus 1 constant. This was what I taught you all. So I'm going to apply this formula and I'm going to find out each of the values. Let's go ahead, and only exception, n should not be equal to minus 1 in this case, remember that. N should not be equal to minus 1. So let's put up the values. X power 2, you are going to get 1 upon 2 plus 1 x power 2 plus 1 minus cos x integration is sin x, so I'm directly writing this as sin x, plus this seems to be x power minus 1. But don't use the formula for x power minus 1 as x power n. I told you the only exception, n should not be equal to minus 1. In this case, the integration is ln x. So write here ln x. Ln x, that's logarithmic value of x, and the base is exponential, that is e. Go ahead, put up the values, we'll get x power 3 divided by 3 minus sin x plus ln x. This is the final answer of this simple integration that we have to perform. Hope that it is crystal clear to you all, it's not too tough. We have integrated each function individually and separately. Integrate this, integrate this, integrate this. So then that is what we are going to obtain. So let me rub this part to go ahead with the next problem. Clear to you all, I believe that, and you are learning and you are practicing with me after each of the questions. Next one. Again, our integration question, integrate e to the power 5x plus 1 upon 2x minus 5. Now remember, whenever you have any general formula and whenever you have a constant multiplied with x, so how you are going to integrate? Now for example, here you see e to the power 5x. What you do, you have to first of all integrate each of these functions separately. So I can write this as integration of e to the power 5x plus integration of, and dx also I should also write to denote it clearly. And yes, in the last problem also write constant in addition with the entire result, that I have not mentioned, but you should mention that, plus integration of 1 upon 2x minus 5 dx. Go ahead, perform the integration. You see here for this problem, just a minute, I went ahead with the last one. Now see here, e to the power 5x, we have integration of, you see here, we know integration of e to the power x dx is equal to e to the power x plus constant. Not a problem, quite simple. Now only thing we have multiplied 5 here. First of all, I am going to tell you a very basic method how to find out integration of such functions, and then I will tell you how to generalize this formula. Now see here, suppose you want to find out integration of e to the power 5x dx. I have told you how to do this. We can take 5x is equal to a new function, that is u. Let 5x is equal to u, and if we take the differential element, we will be getting 5 dx is equal to du. You may write one additional line here. Taking differential element, we are going to get 5 dx is equal to du, or dx is equal to 1 by 5 du. This is what you are going to get. Now can I substitute instead of 5x here u, and instead of dx I can substitute 1 by 5 du. So I will be getting integration of e to the power 5x dx is equal to e to the power 5x, that is e to the power u, and integration of its integration is done with respect to dx. Now dx equal to 1 by 5 du, so divided by 5 and du, not a problem. So we can write 1 by 5 and e to the power u du will be e to the power u, and now substitute u, instead of u you can substitute that as 5x, so 1 by 5 e to the power 5x and then plus 1 constant, not a problem. So remember the result, already I told you the method, remember the result, whenever a constant is multiplied in the function, you have to divide the result with that constant in your result. Remember this result, and you can directly apply it without going through this lengthy steps. So let's go ahead with the solution of the entire problem. Now here we have e to the power 5x dx. So this we got, this is 1 by 5 e to the power 5x. Now what about this? You must be knowing that 1 upon x integration is ln x. Now if you do 1 upon x plus a constant, you will get ln x plus that constant. What I mean to say, again you understand, here I am doing some extra point, you may just switch on to here. You see here 1 upon x integration dx, we know that is ln x. And if I write 1 upon x plus 5, this will be simply ln x plus 5, not a big change. And dx also I should mention here. What if I have 2x plus 5? Then just now as I told you, 1 upon 2x plus 5 dx, constant is multiplied, so in your result that you are going to have divided by that constant. So this will be 1 by 2 ln 2x plus 5 and plus 1 constant in every term you have to add. I believe that the things would be getting with every step, it will be clear to you all. And if you want satisfaction, you can go ahead, you can do the same problem as I told you. You can assume 2x plus 5 as u, and you can go ahead find out the value of dx, that will be 1 by 2 du, and you can go ahead and solve every step, you will get the same result. Now after learning this concept, let's put up the value here. So here you will be getting 1 upon 2 ln 2x minus 5 plus a constant.